thanks, Rachel. I also just wanted to give a shout out to the Learning Analytics Fellowship Program, which was a fantastic experience last winter and really jump-started my involvement in learning analytics at Michigan, being fairly new here, as well as this project. So, as Rachel mentioned, starting mid to late winter term last year, or last academic year, we began looking at all these student comments and course evaluations. And my background is in data mining, and started working with Adam as part of the fellowship program. And so we're just going to share. This isn't going to be 30,000 different plots. It's going to be a sampling of some of the results we've had so far. We're still right in the middle of this project, and so we welcome your feedback of the project. And if there are questions about you'd like us to think about exploring in the data, we'd love to hear your suggestions. So there's already been a lot of great work in analyzing the numeric information that's available on campus about courses and student outcomes. And our goal has been to try to use some of the tools that people have developed, some state-of-the-art tools in text analytics, to try to derive insights from the text that often accompanies the numeric data that we see in course evaluations, in student in feedback from instructors to students, in MOOC dialogue, and so forth. And so what can we learn about from in particular from these comments? The properties of classes, for example, as student learning environments. What are student motivations and needs? What are students saying about their learning environment? Even things like, can we identify interesting trends over time, changes in technology and practice that are evident via what students are saying about their courses? And there are a lot of challenges in moving to text as a source of analysis. It's much harder to analyze, and so it's often ignored, not because people didn't realize the potential is there, because it's hard to glean from the subtleties of natural language or unnatural language in some cases. What's the meaning behind what people are saying? And so some example questions that we've been interested in are, what class factors, as people express them in comments, are associated with high and low course ratings and other variables? What are students saying about their learning environment? And what does it mean when the numbers in the text say different things? So I want to give a special acknowledgement to Phyllis Ford from the Registrar's Office, who we began working with last spring. She did the work to extract for us a corpus of 11 fall and winter terms worth of comments, which amounts to about 21 million words of comments. Which is about 43,000 classes. So just as a point of reference, the next largest study that we're aware of that looks at the text analytics of student comments is on the order of maybe 1,000 classes. So this is at least an order of magnitude larger than any previous study. So the focus of this study so far has been on combining the responses to things like the numeric questions, which many of us are familiar with from course evaluations. The numeric responses to the first 4 questions. Of course, there are many other questions. We focus on these ones because these are the more widely used and responded to. So question 1, I'll focus particularly on question 1 in this talk. The student responds to the prompt of, overall, this was an excellent course. And then there are a number of free-form comment fields that students can fill in. The most widely used by far is the question 900, which is just open-ended comments on the quality of instruction of the course. This list of potential comments goes on, obviously, and eventually we'll look at probably the sort of 5 to 10 most popular, but the volume of data and text for 900 dwarfs many of the others, so we're focusing on that to start with. So more specifically, we took these 21 million words of comment data over 11 semesters and joined them with other registrar data that Phyllis provided us, including the course data on subject area, the type of class, the size of the class, the response rates for the evaluation, the distribution of question scores, but not the individual. So we got individual comments. We didn't have the the individual Q1, Q4 scores to go with those comments, which I understand is more just a technical thing. We have the grade distribution for the class, but not the individual grades. And then also from Mika Levick, we have his data set on instructors. So he sampled 5,500 courses, random sampling of LS&A and College of Engineering courses, to get some demographic data about instructors, their gender and their rank, primarily. So some of the challenges, just off the bat, from you're faced with 21 million words of open-ended comments. The students can and will talk about anything. I mean, you've probably seen this, and that's, and it's an advantage in the sense that students have an opportunity to use the space to say things that aren't really reflectable in the numeric questions. But it makes it very challenging, as you can imagine, to try to categorize the types of things people say and how they say them. The language structure in these comments is highly variable and noisy, to say the least. So in addition to spelling and grammar, people use obviously very informal language. Some of the classes use highly technical terms that have meaning to people in those fields. Emoticons, I mean, you name it. It's just a lot going on in the comments. The response rate for comments is highly variable. Some courses have an excellent response rate. Some have no comments or very few. And as a sort of a side note to that, obviously we're observing the language for a self-selecting group that choose to say something about the course, and I'll say more about that later. There are many subtle linguistic issues in comments. So one thing we've observed from looking at all this data is that students will often mix positive and negative aspects of the course in the same sentence. So say, this is a great course, but the instructor was always late, or things like that. So that makes it really difficult to do things like sentiment extraction and other things. I know you'll find this hard to believe, but students can be sarcastic. And they can use cultural references, idioms. So trying to decipher what somebody says, this course was not terrible. It's a simple case of a comment that sometimes you have to really unwrap. And that's a state-of-the-art linguistic analysis problem. Obviously, there are issues of privacy with this data. People are saying sensitive things about personnel and possibly themselves in the data. So be very mindful of that. And of course, what we can say in the comments reflects what the question asks. We have to really, in analyzing the comments, understand the nature of the question that prompted them. So how are we dealing with these many different challenges? Well, we've been employing a number of tools in our pipeline that I'll talk about briefly. So one of the first things we do when we get the text is, after some initial cleanup processing, we pass it through a natural language processing toolkit. And, we're really interested in trying to get some of the deeper meaning in the language, and so there are a lot of basic techniques that we have and probably will employ, but to really get at things like the fact that people mix sentiment in the middle of sentences. They often will talk about the GSI and the instructor or multiple instructors in the same comment. And so it will pay in the long run to be careful about how the text is analyzed. And to do that, we need state-of-the-art tools. So we're using the Stanford Natural Language Toolkit. It's very robust to noisy data. So it can find sentence boundaries, even with limited evidence of them. It can do part of speech tagging. It can do co-reference resolution, which means if you have a sentence like, the GSI was great, he took care of all of our questions, and although she was busy, the professor was also helpful, and it knows that he refers to the GSI, and she refers to the professor in this case. So different kinds of anaphora and other co-reference resolutions that the system can do. Named entities, people, places, and things. Parsing, being able to identify clauses accurately, so maybe later we want to give some context to some of these phrases that we extract, that's important. And sentiment analysis, so it's a state-of-the-art, it's probably the state-of-the-art sentiment analysis tool that can give us some feedback on opinions that are being expressed. In addition to the natural language processing, we have a number of other tools that deal with language. There are statistical readability models that actually I've developed in a separate line of research that are robust in these kinds of noisy text situations, so where flesh concave and other things fail, I'll show you some interesting results from the method I developed. We use topic modeling to get at the topic structure of comments. So can we take these 22 million words of comments and sort of categorize, let's say, 100 different topics that come up again and again? Often, and these topic modeling algorithms can model an individual comment as a mixture of topics. So a topic could have positive sentiment combined with talking about chemistry, combined with talking about the fact that there was some controversial element to the course. So all these things could be, in theory and in practice, reflected in topic modeling. And we use a technique called online latent Dirichlet allocation for that. I mean, this is a fairly large data set for some of these problems. So I'll explain how we're dealing with that volume of data later. Something called turbo topics, which finds interesting sequences of words. We use text regression, and the idea of text regression is basically, can you predict, say, the Q1 score of a course from the words, phrases, and n-grams that are there? So that's the situation where you're dealing with 100,000 input variables to predict this one output variable. So the question would be, for example, how does the language of what people say change with high and low scoring courses, or with instructor seniority, or their gender, and so forth? And in the future, we would like to do more sort of aspect-based opinion mining that gets at combining the topic modeling with some more context. So I'm just going to share a couple of very simple basic statistics, first of all, about comment response rates. So how often do people write comments, and how much do they write? So this number calculates the percentage, so of the people who responded to the evaluation, what percentage of them left at least one text comment for the Q900 question. We're just curious to see whether this rate is consistent over time, and it appears to be. So roughly, at least in this data set, roughly just over half of the people who responded to the evaluation left at least something in the form of a text comment. We can also look at response rates as a function of class size. So we're able to we're starting to combine aspects of the text with aspects of the numeric properties of the course. So we can look at the class size. And we can see it's actually fairly steady across class sizes. So class, I defined four classes here, four categories of size. And the rate is fairly stable again across the size. The large classes tended to have slightly lower average response rates, but on the whole it was pretty steady. So then we can ask, okay, of these students who are responding to comments, when do students write more and when do they write less? So one thing you can do is look at the subject. So we partition the classes by subject. So who writes the most comments and who tends to write the least comments? Well, in this data set, students in education courses wrote the longest comments on average. So the y-axis here is the mean sentence count per respondent, given that they have left a comment. And so students in education, art, design, and social work classes tended to leave longer comments. And maybe somewhat appropriately to their economizing, the economic students tended to write the shortest ones, along with people in math and ECS. Somehow that's not terribly surprising, but it's interesting. Okay, so these are some of the sort of standard overall statistics that we can compute. How am I doing on time?
You're good, 25.
So then we can move to actually